Okay, so yesterday we talked about segment addition and points that are in between other points on a segment. Today we're going to continue with that pattern but go into a little bit more detail. So, to start with example 1, they want us to solve for x and find the length of segment BA and the length of segment AD. All we know is that A is in between A and D. We don't know anything more specific. So, we do know this part, and the whole thing. That's a segment addition problem. I can take 2x plus 4, add 4x minus 4, and set it equal to the whole thing, which is 24. Now I combine my like terms. 2x plus 4x is 6x. Plus 4 and minus 4 is 0, so that goes away. So 6x equals 24, or x equals 4. The second part of what they want is to find segment BA and segment AD, or the length. So I'm going to substitute into here. 2 times 4 plus 4. So that's 8 plus 4 is 12, and 4 times 4 minus 4 is 16 minus 4, or 12. What we found here is that segment BA and segment AD both have a length of 12. That makes them congruent segments. Those are segments that have the exact same length. This symbol here is the symbol we use to show congruent. It's kind of like an equal sign with a little squiggle above it. We're going to use that symbol quite a bit here during this school year. Because BA and AD are congruent, that point A has cut the whole segment, segment CD, in half, or we say that it bisected that segment. It's a segment bisector. And then the other key word we use is that we call A midpoint. And we call it a midpoint because it is the exact middle, geometric middle of that point, or of that segment. Example 2. Similar to what we did yesterday, but a little bit different, because now I'm not saying that R is between A and C, I'm saying R is the midpoint. So I would draw segment AC, and now I am going to place M, or R I should say, in the exact middle. Now, we don't have to find the exact middle, we need to be really close. The way that we're going to differentiate between R being just between A and C and R being the midpoint is we're going to use these little tick marks. Those tick marks show that this segment AR and this segment RC are congruent. That's the conclusion we can draw. Segment AR is congruent to segment RC. We know that based on the tick marks. If I were to put 2 tick marks here and 1 tick mark here, now I'm saying they're not congruent. That's how I can show that they are not. Again, if I wanted to show that they are, I'd add a second one here. So the tick marks, anytime you have 2 segments with the exact same mark, then you know those 2 segments are congruent. If the marks are different, the segments have different length. So, down here, we could name which segments are congruent in this diagram based on the tick marks. I know that segment RO has the 2 tick marks, so I look for another segment, in this case segment SI, that also has 2 tick marks. So I would say that segment RO, when I'm writing this, I need the segment bar, I need the congruent symbol, and then segment SI with the segment bar. In addition, though, I have segment OW with that circle, and segment IT with that circle. Those 2 segments are also congruent. So I would say that segment OW is congruent to segment IT. The last question here for this example is point O a midpoint? And I want you to think about that. In order for it to be a midpoint, it needs to cut the segment it is on in half. Since RO and OW are not congruent, then no. O is not a midpoint because it does not cut that segment in half. The last example on this page is example 4. It's our first algebra example. It says that M is a midpoint of segment AC. I know that those two segments then have the same length. This is not a segment addition problem now. In order for this to be segment addition, I would need to know the length of segment AC, and I don't. But because this is a midpoint, and only because it's a midpoint, I know these have the same length. Or, I know that segment AM equals segment MC as far as their length. Since AM is 3x minus 2, I know that MC is 2x plus 4. I now have an equation I can solve for x. If I subtract 2x from both sides, add this 2 to both sides, 3x minus 2x is 1x, that cancels, x's cancel, 6. So I now know that x is 6. Once I know that, I can substitute in to find each segment length. Segment AM is going to be 3 times 6 minus 2. Well, that's 18. Minus 2 is 16. Segment MC. Well, that's 2 times 6 plus 4. 2 times 6 is 12. 12 plus 4 is 16. I know I'm right because those are equal. And they should be since M is the midpoint. The last thing they ask us to find is segment AC. Now I can do segment addition, because now I know that this is a length of 16, and segment MC is a length of 16. If I add those two together, I know that segment AC has a length of 32. Okay, you can go ahead and move on to the notes for page 2.